Hey, guess what this video is about? Well, yeah, that kind of gives it away here. This is about factoring out the greatest common factor from an expression, and we're also going to talk about factoring by grouping. But first, factoring out the greatest common factor. So that's when you have a bunch of terms, an expression that has more than one term added together, and you look at all the terms and you try to find what they have in common, what factor they have in common. And if there's more than one thing, you're looking for the greatest common factor, the one that's bigger than anything else. Like when I look at this, I see three terms. There's a 36y cubed, there's a minus 12y, and there's a 32. And right away I notice all these numbers are even numbers, so they're all divisible by 2. 2 would be a common factor, but it's not the greatest common factor. I can think of a number bigger than 2 that they all have in common, and that would be 4. Now, if I just looked at the first two, they're both divisible by 6 or even 12, but the 32 is not. So if I want something that all three of these numbers are divisible by, the greatest common factor is 4. So I can write each one of these numbers as 4 times something else. The 36 would be 4 times 12. The 12 here would be 4 times 3, and the 32 could be written as 4 times 8. And since they all have a 4 in common, I can pull that 4 outside parentheses and leave the something else's inside the parentheses. So after factoring out that 4, I've got 4 times the quantity 12y cubed minus 3y plus 8. Now, if you multiplied that back out with the distributive property, you would end up with what we started with. The 4 times 12y cubed gives you 36y cubed minus 12y plus 32. Let's try this one. 6x squared minus 18x plus 6. What's the greatest common factor here? What's the biggest number that these are all divisible by? Well, that's actually 6. These are all 6 times something. What are the somethings? Well, this is 6 times x squared. This would be a 6 times a 3x with a minus in front of it. And this 6 here, if we want to think of it as 6 times something, that something would have to be 1. So we've got 6 times x squared minus 3x plus 1. And remember, you can always check by multiplying it back out and making sure you get back where you started. Let's try this one. We have minus 10x squared minus 25xy. Okay, these numbers are both divisible by 5. They both have 5 as a common factor. And they are both negative, so I could factor out a negative 5. They're both negative 5 times something. So I could put the negative 5 outside the parentheses, and then it would be 2x squared. And this would be a plus because we pulled out the minus. So it's negative 5 times 2x squared plus 5xy. But there's actually something else we can do. Look at what's inside the parentheses. We got a 2x squared. We got a 5xy. Now they have something else in common. Can you see what that is? That would be an x. These are both x times something else. The 2x squared would be like an x times a 2 times another x, and the 5xy would be like an x times a 5y. So if we pull out the x that they have in common, put it outside the parentheses, now we've got minus 5x times 2x plus 5y. And now it is factored completely. So the greatest common factor could have a number part, and it could have a variable part, could have either one or both of those. Here, the greatest common factor was minus 5x. Once we pulled that out, then the part inside the parentheses, there wasn't anything else that these had in common. What about this? 4y squared minus 7y. The 4 and the 7 don't have any common factors, other than just 1. But the variable parts do have a common factor of y. So we can pull out a y, and then what's inside the parentheses would be 4y minus 7. we need y times 4y to get 4y squared, and we need y times the minus 7 to get minus 7y. How about this one? X to the fifth minus 10x to the fourth. What's the greatest common factor? Well, when you look at the variable parts, these both have x to at least the fourth power. They both have at least 4 x's. X to the fourth, remember, means x times x times x times x. And x to the fifth would be x times x times x times x times another x. So if we pull out the x to the fourth, what's left is that one other x minus that 10. So it's x to the fourth times x minus 10. What about this? 6x to the fifth minus 9x squared. Can you see what the greatest common factor is here? Now, hint, this one, it's going to have a number part and a variable part. The number part is the biggest number that's a common factor of 6 and 9. And the variable part is a common factor of x to the fifth and x squared. So that would be 3x squared. And then you got to think, okay, 3x squared times what gives you 6x to the fifth? And 3x squared times what gives you the minus 9x squared? So here's the answer. It's 3x squared times 2x to the third minus 3. Okay, what about this? There are 3 terms. We're looking for the greatest common factor that all 3 terms have in common. And it might have just a number, might have a variable part, might have both of those. Here it does. The greatest common factor is 8x. 8 is the biggest number that's a factor of 24 and 40 and 8. And x to the first power is the biggest power of x that appears in all 3 of these terms. And when we pull out the 8x, what's left is 3x squared minus 5x plus 1. Now let's talk about factoring by grouping. This is something to watch out for when you have 4 terms, 1, 2, 3, 4, and there's nothing that all 4 of them have in common. So like here, there's no common factor that x to the third and 8x squared and 5x and 40, all 4 of them have in common. But if we sort of group them together, look at the first 2 of them, and then look at the last 2 of them. What do the first 2 have in common? X squared. We can pull an x squared just out of those first 2. And what do the second 2, the last 2, have in common? What can we pull out of those? 5. So when we pull out x squared times x plus 8, plus we pull out 5 times x plus 8. Oh, look! Oh, I see something exciting. I've got an x plus 8 here and also here. So this green part and this red part have a common factor of x plus 8. And I can factor that out. I can pull out the x plus 8 times the x squared here plus the 5 here. So now it is factored because the whole thing is written as something times something else. X plus 8 times x squared plus 5. Or if you'd rather write those in the other way around, you can put the x squared plus 5 first times the x plus 8. And notice we can check our work by multiplying this back out, like with the FOIL method. First we get x squared times x, that's x cubed. Outside we get x squared times 8, that's 8x squared. Inside we get 5 times x, that's 5x. And last we get 5 times 8, that's 40. So yay! Let's try another one of these. So for the first 2, we can pull out 2x squared. 2x squared times x minus 10. And for the last 2, we can pull out what they have in common, which is 3, or really since there's a minus in front of this, let's pull out negative 3. So this would be a negative 3 times an x, and then this plus 30 here would be like a negative 3 times a negative 10. This would have to be a minus 10 so that this negative times this negative gives us a positive. And now, what do these have in common? If they didn't have something in common, then this wouldn't work, and we wouldn't be able to factor this by grouping. But they do have something in common, the x minus 10. So we can pull that out, and now it's 2x squared minus 3 all times x minus 10. The end. Well, you can check by foiling, but this is the correct factoring. Yay, we factored by grouping.